Welcome to the Cow Corporation's series of videos about software engineering. The topic of this video is Insert-Iterators. Before proceeding, make sure that you have already watched these other videos first. This function copies a source vector's items into a destination vector by using assignment and forward iteration operators, applying them to both source and destination iterators. C++ has a built-in copy algorithm which has been implemented similar to this code, except the built-in implementation uses templates so that it can generically copy from any kind of collection to any kind of collection. As written, this copy algorithm assumes that the destination collection already has at least as many items as the source collection, so that there's enough room for iteration over the destination while data is being copied into it. But now assume our goal is to have a copy by insertion behavior instead of that copy by overwrite behavior. Our goal is to be able to start with an empty destination object and copy data into that. But here's the real challenge. We want to be able to do that copy by insertion, still using the same code for the copy function. At first, this might seem like an impossible mission. This copy function was programmed to do a copy by overwrite. How can the same code also somehow do a copy by insertion? The trick is we do allow ourselves one small change. We let ourselves use a different data type for this parameter. Remember that STL's actual implementation of this copy function uses a template, so STL doesn't even need to change anything in their code. To do this trick, their template merely needs to get specialized differently. This copy code applies assignment and forward increment operators onto its parameter whose type is t. Before, when t was an ordinary iterator, those operators did the obvious things. The assignment operator assigned some value to one of the destination's items, and the forward increment operator moved on to the next destination item. That's what produced its copy by overwrite behavior. But now we can define a different type for t and implement that different type for t in such a way that it does copy by insertion instead. Instead of actually doing an assignment, we now want the assignment operator overload to call pushback. Doing that will cause insertion into a destination object, which used to be empty. And instead of actually moving the iterator pointer, we now want the forward increment operator overload to do nothing. STL already provides a built-in class that does this new behavior. It's called a back insert iterator. Because this back insert iterator relies upon being able to call pushback, you're not able to use this trick with those collection classes like map, which cannot handle a pushback call. For the convenience of not needing to manually define your own back insert iterator variable, STL also defines a global function that produces it as a compiler temporary within your list of parameters being passed to copy. Imagine that we use this same back insert iterator trick, except that now we redefine the assignment operator to call push front instead of push back. Again, we'd get a copy by insertion behavior, but now we'd also be reversing the order of the data while it's being copied. STL provides another class called the front insert iterator, which has been implemented using that push front call. Again, you don't need to manually define your own front insert iterator variable if you instead use STL's global function that produces it as a compiler temporary. There's also a third way that you can use this video's trick. STL provides yet another class, this one named Insert-Iterator. Instead of calling push back or push front, this Insert-Iterator class converts the assignment operator into a call to the insert function. The advantage of doing that is that the insert function can also be used with sorted collection classes like map. The disadvantage of converting assignment into a call to the insert function is that this insert iterator needs to initially record some iterator position, which it will then continuously reuse in its calls to insert.